Welcome back to Todd 2V's journey of exploring the universe. Dear friends, in the previous journey, we visited the Boomerang Nebula, a nebula located 5,000 light-years away. This is a very great distance for humans, but it's actually tiny compared to the size of the universe. So, beyond the 5,000 light-year space, what celestial objects will we encounter? Let's explore with Todd 2V in today. Wishing you an enjoyable video view. And now, please fasten your seatbelts to continue the journey. Come on, let's explore together. Passing the Boomerang Nebula, the ship's clock shows a distance of 5,100 light-years from Earth. The ship is flying straight in the direction of the Scutum constellation as observed from Earth. Look, do you see it? That is the largest star known to humanity, Scuti. This is a red supergiant star with an apparent magnitude ranging from 8.29 to 10.56. Therefore, it is a variable star with a fluctuation cycle of 740 days. We cannot observe this star with the naked eye from Earth. Thus, this is a rare opportunity for you to observe and admire the star. The special feature of Scuti is its super large size. It is known as the largest star in the universe discovered by scientists. According to calculations, its radius is approximately 1,708 plus or minus 192 times that of the Sun. With this size, if converted to kilometers, the star's maximum radius is about 1.3 billion kilometers. Scientists believe that if the Sun were replaced by this star, its radius would extend to the orbit of Saturn, the sixth planet in the solar system. And if our Todd 2V spacecraft were to travel at the speed of light, it would take 7.6 hours to fly around the star once. There is a paradox that although Scuti has a super large size, its mass is estimated to be only 7 to 10 times that of the Sun. Therefore, the average material density of the star is about 1 billion times lower than the density of water. This means if there were a large enough ocean, Scuti could float on the surface. Additionally, scientists believe Scuti is in the final stage of stellar evolution. Its outer shell is expanding strongly while gravity compresses material into the core. The consequence of this tug-of-war will end in a glorious supernova explosion. Scientists estimate the star will become a supernova in the year 2900, about 300 years from now. When the explosion occurs, we on Earth could witness a light feast created by the universe. But if unfortunately, the radiation beam from the explosion is directed straight at Earth, then life on Earth would certainly be wiped out by the terrifying energy of the radiation beam. Hopefully, when the explosion happens, the radiation beam will not be aimed directly at Earth. Currently, Scuti has a surface temperature of about 3,600 degrees Celsius, much lower than the Sun. But due to its super large size, the star's brightness is about 86,300 times that of the Sun. This truly is a superstar in both literal and figurative senses, isn't it? Passing the star Scuti, the Todd 2V spacecraft will have a long journey. We are heading straight to the Eagle Nebula, a very famous nebula in astronomy. Look, we have arrived at the nebula area. The time clock shows 5,700 years. This means the nebula is about 5,700 light-years away from Earth. At a glance of the nebula, we can see very large pillars of gas and dust. The tallest gas pillar in the northern part of the nebula is about 9.5 light-years in size. That means light takes about 9.5 years to pass through the size of this gas pillar. Additionally, there are many stars in this area of dust and gas pillars. According to calculations, the nebula has about 8,100 stars they are mainly concentrated in this largest gas column. There are many blue supergiants in this area. They are all very hot and bright, but most of these stars are quite young. It is estimated that their age is only about 1,000th that of the Sun. To fly through this nebula, it will take us quite a lot of time. Please take the opportunity to rest and admire the beauty of this nebula. Our spacecraft has passed through the Eagle Nebula. In this area, you can see that the surrounding space is quite quiet. Oh, the ship is vibrating again. It has entered an area with an extremely strong gravitation. At this moment, the time clock shows about 6,100 light-year. Perhaps we are approaching the area of the black hole Sinus X1. This is an extremely strong radio emission source in the direction of the Cygnus constant. It was discovered by scientists in 1964. According to calculations, this black hole has a mass only about 14.8 times that of the Sun. This means its event horizon is very small, estimated to be only about 300 kilometers. This is considered a super small black hole in the universe. Accompanying this black hole is a blue supergiant star. It is named HDE 226868. According to observations, it is only about 0.2 astronomical units, or 30 milli. Material from the star is being pulled into the black. The matter in the black hole's accretion disk is heated to millions of degrees Celsius, producing an extremely strong X-ray beam observable from Earth. According to calculations, this binary system orbits the center of mass every 5.99 days. Scientists believe that this super small black hole may have been formed from a supernova explosion of a star with a mass about 40 times that of the Sun. As for the companion star, at present, its radius is about 15 to 17 times that of the Sun. Based on stellar evolution models, scientists estimate its surface temperature to be around 31,000 degrees, but the star's brightness could be 400,000 times that of the Sun. This is truly a super bright star, isn't it, everyone? Please note that since our spacecraft is flying quite close, we should avoid looking directly at the star with the naked eye. Please wear protective glasses to observe and admire this star. After passing black hole Sinus X1, we will head straight to the star VKFR 136. As we know, stars with the VKFR designation have unusual and rare spectra. The prominent broad emission lines of helium, nitrogen, and carbon are all highly ionized. Typically, these stars have very hot surface temperatures. Look, do you see it? That is the star VKFR 136. At this moment, the time clock shows 6,700 years, meaning this star is about 6,700. At present, VKFR 136 has a mass about 21 times that of the Sun, but its radius is only about 5 times that of the Sun. What is notable about stars with the VKFR designation is their very high surface temperatures. According to calculations, VKFR 136 has a surface temperature of up to 70,800 degrees Celsius. More than 12, with a mass and size larger than the Sun. Scientists measure the star's brightness to be about 600,000 times that of the Sun. Please try to imagine, our Sun is already so bright, but VKFR 136 is 600,000 times brighter, so we can't even imagine how dazzling it would. According to scientists' calculations, the age of this star is estimated to be only about 4.7 million, a very young age compared to the Sun's 4.6 billion years. Additionally, this star is at the end of its life cycle and may only exist for a few thousand more years before a supernova explosion occurs. Interestingly, scientists have found some evidence suggesting that the star VKFR 136 has a companion. It might be a star of spectral type K or M. It orbits VKFR 136 with a period of about 5.13 days, but scientists have not yet observed it. During our journey passing by this star, please observe carefully. Who knows, you might be the first to discover this companion star. After passing star VKFR 136, we will have rest time before the ship continues to take you to explore another location. Another warning about the extremely strong gravitational field. Currently, our clock shows approximately 7,000. In this area, we are probably approaching the black hole LB1. At this moment, we are in the direction of the Cygnus constellation. Viewed from Earth, this black hole is known because it accompanies a star named LB1A. This is a spectral type B star, orbiting its companion black hole with a period of about 78.9 days. And of course, when accompanying a voracious companion, it is gradually having its material sucked away by the black hole through stellar rain. Since black holes cannot be observed directly, scientists only know about them through their gravitational influence on surrounding celestial. They estimate that black hole LB1 has a mass about 70 times that of the Sun. This is a relatively small black hole within the stellar mass range. Scientists believe that the predecessor of black hole LB1 was large enough to undergo a pair instability supernova, and it completely vanished, leaving no remnant after the supernova explosion. There is also research suggesting that LB1 might not be a black hole, but instead, it could be a binary star system consisting of a rapidly rotating B star and a slowly rotating. This system is thought to have formed through a past mass transfer event. After leaving the main sequence, the predecessor star transferred mass to its companion and became a very rapidly rotating B star. But this research has also received mixed reactions from the scientific community. Most researchers still believe that LB1 is a black hole. After passing black hole LB1, we are approaching an area with a spectacular view, which is the Bubble Nebula. It is also known as Nebula NGC 7635. This is a nebula in the Cassiopeia constellation, 7,100 light-years from Earth. In fact, the Bubble Nebula is created by stellar winds from a very young star. It is designated as BD plus 60 degrees 2520. This is a supermassive star, weighing about 44 times the mass of the Sun. Additionally, it also has a huge size, with a radius about 15 times that of the Sun. Scientists believe that although this star is about 2 million years old, the Bubble Nebula was probably created only about 40,000 years ago. With the star's apparent magnitude of 8.67, when observing from Earth, you only need an 8 to 10-inch telescope to see this nebula. At that time, you will see a fragile membrane around the star, which is the Bubble Nebula. Since this nebula is created by material from stars through stellar winds, it is expanding outward at supersonic speed. According to calculations, these stellar winds have speeds from about 1,800 to 2,500 kilometers per second. Therefore, they cause the central star to lose about 1/millionth of the Sun's mass each year. Additionally, this star is very hot, with a surface temperature reaching 37,500 Kelvin, about 6.5 times that of the Sun. Thus, the star has a luminosity 398,000 times that of the Sun. Another interesting thing is that this nebula and star are moving toward the solar system at 26 kilometers per second, which is 93,600 kilometers per hour. Passing through the Bubble Nebula, we will head straight to the Eta Carina star system. At this time, the spacecraft clock shows 7,500 years, meaning this star system is about 7,500 light-years from. This star system is known for having at least two supergiants with luminosities of 1 million and 5 million times that of the Sun. You didn't miss here, a star 5 million times brighter than the Sun is real. This star is named Eta Carina A, a supergiant with a radius about 240 times that of the Sun. In terms of mass, it weighs from 120 to 200 times the mass of the Sun. These are truly astonishing numbers, aren't they? According to scientists, this star has lost a mass approximately 30 times that of the Sun. It is expected that in the near future, the star will explode and become a supernova. This is also the only known star in the universe that emits ultraviolet laser radiation, a phenomenon we have never seen in any other star. Additionally, surrounding this star system is a nebula of the same name, the Carina Nebula. This is a massive star-forming region. This nebula can be observed with the naked eye in the southern sky. It appears near the constellation Carina. Although the Carina Nebula is 4 times larger and even brighter than the famous Orion Nebula. Because it is located in the southern hemisphere, it is less well known than the Orion Nebula. From this, we can see that our Sun is very small when compared to the supergiant stars in the beyond the Eta Carina system. We will fly straight to the V404 Cygni black hole. This is a black hole located in the region of the Cygnus constellation, about 7,800 light-years from Earth. According to calculations, this black hole has a mass only about 9 times that of the Sun. Accompanying it is a G-type main sequence star. This star has a mass only about 60% that of the Sun, but its radius is about 6 times the radius of the Sun. According to scientists' records, this star orbits the V404 Cygni black hole with a fairly fast period. It takes only about 6.47 days to complete one orbital cycle. In 2009, this was the first black hole to have its distance accurately measured using parallax relative to. The measurement was made using very long baseline radio interferometry and the results showed a distance of 2.39 kiloparsecs, equivalent to 7,800 light-years. In April 2019, astronomers reported that the particle jets emitted from the black hole were oscillating back and forth periodically over, something they had never seen before in black hole particle jets. Astronomers believe that this oscillation is due to the frame dragging effect of spacetime, which is created by the extremely strong gravitational field in the vicinity of the black. When the spacecraft arrives here, we can see that, even though we are on a spacecraft with the fastest imagined speed of all time, we have been traveling for about 7,800 years, yet we have only covered a very small corner of the Milky Way galaxy. Beyond this vast universe, there are billions of other galaxies, and it's unknown when we will ever reach the end of the universe. Before the spacecraft takes you to explore other mysterious areas, now please take some time to rest to ensure your health before exploring new lands. Wishing you an enjoyable video view, and now please continue to select the video on the left or right side of the screen to enjoy decoding other mysteries of the universe together. Looking forward to seeing you in the next video. Goodbye, everyone.